Our next speaker, he's coming from us. He's right here in Little Rock, Arkansas, and he's going to give a great talk about the last 500 million years of natural history in Arkansas. So let's all give a warm welcome to Mr. Joseph Daniel.
Oh, good afternoon. Thanks for coming. I want to thank the organizers of the event for asking me. I've been dealing with the legislature all week, so this is a really welcome change. So one of the things that I spend a lot of time on is paleoerie.org. This is a website that I created wherein I talk about all things evolution. Reason for that, you've heard some of it. But there are so many websites out there that give so much bad information. I wanted to put one up there where you could feel comfortable going to it knowing that all the resources on there have been checked by an expert. So one of the things that I do with this is I also talk about fossils, particularly Arkansas fossils. And I do a lot of talks at schools. I'll take fossils to the kids and show them. I help train teachers, that sort of thing. And one of the things that has been abundantly clear is that there are very, very few people who have any idea of the natural history of Arkansas. Now, when people think about fossils, they don't usually think about Arkansas. But we really do have a rich diversity of fossils here. And the history of Arkansas is far more extensive than most people think. So I'm going to start with geology and just a brief introduction to the geology of the state. Give a foundation for the rest of the talk. And also because our natural history is not just what lives in the state, it's the land itself. So this is a geological map of Arkansas, and it shows all the rocks in the state, categorized by time. And one of the things that is very obvious is there are two parts of Arkansas. We've got the hilly side and the flat side. And this is broken up into several groups. If you go to, one of the things I really like about Arkansas is that if you start in Little Rock, pretty much any direction you go, you're into a different type of geology. So it makes Arkansas a really nice place to train geologists. So if you go up to the Ozark Plateaus, this is an area that there was a giant magma chamber which just lifted up the entire part of the state, along with portions of Oklahoma and Missouri. You got the Arkansas River Valley, which you got a river that started in Colorado and came all the way through here and cut through. You got the Ouachita Mountains. Pulaski County is right here, right in the center of everything. Arkansas is the best place to study geology for that. The Ouachita Mountains, it's actually the tail end of the Appalachian Mountains. It's the oldest mountain group in North America. It's one of the oldest in the world. That was caused by when North America crashed into Africa, crumpled up the whole edge of the continent. So next time you have a fender bender, you can say, well, at least I didn't break the continent. And we've got the West Gulf Coastal Plain, and this area is when the ocean came all the way up to the Ouachitas. And then the Mississippi River put a bunch of sediment on the east side of the state. Out of all the rock units in Arkansas, my favorite is probably the Atoka Formation. It's in the Arkansas River Valley and top part of the Ouachitas. It's mostly shale and sandstone. There's a little coal and stuff in there. The reason that I like it is that it shows an entire sequence from basically the bottom of the ocean all the way up through deltaic sediments into rivers. So in one unit, you've got the entire depositional sequence, which I think is pretty cool. So this is a simplified geological map. Basically, you've got the red is very early Paleozoic, so it's the oldest rocks. The easiest way to break this up is that from here up is before the dinosaurs. This green is dinosaurs, and the rest of it is after the dinosaurs. So we've got Paleozoic through here, little Mesozoic, and then Cenozoic. So there's a spot. Let's see if it shows up there. Yeah. That one spot there, that is an interesting place. It's called Magnet Cove. And because of its unusual geology, it's a very popular spot for mineral collectors. There's a wide diversity of minerals you can get there. There's garnet, rutile, quartz, of course, magnetite, and a variety of others. And at this spot with the star, right down, we got the Crater of Diamonds. This is the only diamond mine in the world where anybody can come and mine diamonds. Then, of course, there is the Arkansas quartz, which we are world famous for this. You can go to museums across the world and find Arkansas quartz. I've been to Paris and Romania, places, and go all this distance to find rocks right here from home. Okay, so this is the geologic timetable, and just to make it, we've got the Paleozoic down here. This is the very beginning with the Cambrian. You've got the early Paleozoic and the Mesozoic and Cenozoic up there. So I'm going to do the rest of the talk based on that in that order. Come on. There we go. So this is we start in the early Paleozoic in the Ouachita Mountains. Now there's not a whole lot in the Ouachita, so we'll get them out of the way real quick. These are sediments that were put down in primarily deep ocean. And what we have there, we've got some trilobites. We also have graptolites and conodonts. Now the reason these are important is the graptolites, they're still alive today. We call them terebranchs. These are hemichordates, which basically means this is the closest that invertebrates get before they become vertebrates. So they are right at the edge of the transition from invertebrate to vertebrate. The conodonts, on the other hand, are right after that. So they are the first animals that really start developing bone. So they just have teeth. And talking about size of them, we can leave the philosophers to talk about angels dancing on the head of a pin. We can actually count the number of conodonts on the head of a pin. So these are really kind of weird, sort of eel-like animals. And if you want to see what their teeth were like, this is a picture of a frilled shark. These aren't related to conodonts, obviously, but their teeth would be very similar to that. So moving up into the Ozarks, this is mostly Middle Paleozoic era. And this is an area that you can see pretty much everything from, it's mostly shallow marine, up through river deposition. Most of it said is the shallow marine. You sort of think of it like the Bahamas. So that's what the Ozarks used to be like. And so this is a picture of some of it. You go up through I-65, go up through Leslie and Harrison. There's some great views of the rocks there. And so this is what some of them look like. This picture shows what it would have looked like 400 million years ago. So some of the fossils that we find there, we've got bryozoans like Archimedes there. We've got, of course, brachiopods, which a lot of people think that they're clams. They're not actually related to clams. We've got tabulate and horn corals. These are not corals that you see today. These have all gone extinct, and they've been replaced by an entirely different set of corals. And we've got, of course, trilobites, we've got crabs, we've got blastoids and echinoids. These are sea urchins. And we've got probably the most common fossil in Arkansas are crinoids. And crinoids, this is one of them that's actually still alive today as well. In the past, they were all over the place. They are really, really common in these rocks. Today, the only place that you're going to find them is sort of deep ocean, close to the right at the end of the continental shelf, and they're not nearly as common today as they used to be. But the one that I really want to talk about is this one right here. This is Rhinoceros. This is a shelled cephalopod. It's an ammonoid. A lot of people are familiar with ammonites, but ammonites are just a subset of the bigger ammonoid group that this is in. So the only ones living today is the nautilus. The nautilus is closely related to all these shelled squids. A lot of people collect their shells because they've got very pretty shells. But in 2003, a group of students found an 8-foot-long cone. So this is one of the straight-shelled versions, and it is the largest one of these ever found. This is what it would look like when it was alive. This is, as far as this type goes, it's the largest in the world. There is one other species that got bigger than this, but there's only a couple of samples of that that are bigger than that one. So this is another fossil that was found up near Leslie. It was found right about there. And this one actually made international news. It was talked about by people in China and Asia and Europe. I got interviewed on TV for this fossil. And if you get interviewed in Arkansas for paleontology, it's a big deal. So it doesn't look like a whole lot. But if you CT scan it, you find fossil inside of it. And what this is part of the skull and the gill supports of a very early shark. Now sharks, you know, they have cartilaginous skeletons, so they don't really preserve very well other than their teeth. So these are really rare. And this one is the oldest one ever found. So this is 325 million years ago. And the reason that this one is important is this is what it would have looked like alive. It's what they call a falcatus. It's got a really weird spine on top of its head. Now the reason that this is important is because it's relationships. You've got the sharks over here, and then Ozarchus, which is what they named it, right here. So they're more closely related to the sharks. You got the bony fish over here. You notice that the gill supports look a lot more like the bony fish than they do the sharks. So the traditional idea has been that bony fish evolved from a shark-like ancestor. Kind of makes sense. You go from a cartilaginous skeleton to a bony skeleton. Turns out that's not the way that it seems to work. The sharks evolved from a bony ancestor. So in a way, you could kind of say that they are more evolved than the bony fish. So next time you go swimming in the ocean, if you get attacked by a shark, you can at least say that you were attacked by a very highly evolved animal. So we get into the end of the Paleozoic, at the Permian, we're into the Mesozoic now, the Triassic and Jurassic. And this is a really important time in the planet. So this shows a little bit of the diversity of life during that time. In the Permian, we got the synapsids, which are the ancestors of mammals, and they pretty much ruled the Permian. But then you have the biggest extinction event in the history of the planet. And depending on who you talk to, up to 96% of all life on the planet died. So not a whole lot left afterwards. What did make it through was some of the mammalian ancestors. But they didn't stay very long. They got replaced by the ancestors of the crocodiles. But we had another extinction event. Right at the end of the Triassic, the dinosaurs started showing up. They weren't very numerous at this point, until this late Triassic extinction event, where almost all the crocodilians died off, leaving the world to be taken over by the dinosaurs. Unfortunately, we have none of these rocks in the state, at least not on the surface. All of them that were deposited in Arkansas got eroded away as the land was uplifted. You can find some Permian rocks in Arkansas if you want to dig a rather long ways down into the ground. But we do have Cretaceous rocks, and there's a lot of stuff that's been pulled out of this. So this is, during the Cretaceous, there was an inland sea, which basically made the Rockies a very large island. Arkansas is right down here, and we were right at the coast of that ocean. So we have Cretaceous rocks that are both coastline and marine. So this is what part of it would have looked like back then. We have some of the largest animals that ever walked the earth, and these long-necked titanosaurs. We also have a carnivore. It's called Acrocanthosaurus. It's a descendant of Allosaurus. And we know that we don't have any bones of these dinosaurs. What we do have is trackways. And there's 2 sites of these dinosaur trackways. But between the 2 of them, it's estimated that there are anywhere between 5,000 and 10,000 footprints there. So one of the largest trackways in the world. At least it was until they got torn up. There's a few of them that have been preserved and left, and they've all been mapped. Unfortunately, this was found in a commercial quarry. They were kind enough to let people come in and study it and map it and take a few samples, but said it was a commercial quarry. Now you can go to Mid-America, at least you used to be able to. I haven't been there since they renovated, but they had one of the big titanosaur footprints there. The only dinosaur bones that we found are these bones. Basically, we've got the foot of one dinosaur. And this is roughly what it looked like. I know the picture is a little fuzzy, and that's fair, because with only having 1 foot, it's really kind of hard to say exactly what kind of dinosaur it is. But it looked something like that. Now, this was at the coast. Other animals were at the coast. Such as Goniopholis, say a primitive crocodile. There's a really nice skeleton of that has been found, which unfortunately right now is languishing in Austin. We also, probably the most common fossil that you find down there are these clams called Exogyra ponderosa. And these are oysters. And the picture over there is an oyster bed of today. So you can see just how packed they get in. If you go down there and try to collect these, you can collect thousands of these really quick. I would probably say within a few days, we could collect enough to put one of these fossils in every school in the state. So they're really, really common. But we also have the marine fossils, and these are the ones that we get more of than anything else. There are sharks, there are ammonites, there is Encotus down here. It's called the saber-fanged herring, which is a really bad name. It should be called the saber-fanged salmon. Then we've got elasmosaurs. Now, elasmosaurs were marine reptiles that, to give an idea of the size of these animals, if you take a car, put a python at one end and a tail on the other, and flippers at least as long as my arms, that would be an elasmosaur. And so we found some really nice fossils of these. Probably the king of the oceans back then were the mosasaurs, and we found some really, really nice mosasaurs here. These, get an idea what a mosasaur is? Everybody's familiar with Komodo dragons, right? Well, put flippers on a Komodo dragon and make it 2 to 5 times that size, and that's a mosasaur. We also have some really early birds, the Hesperornithids. These are very early diving birds. So there's actually got a lot of interesting Cretaceous fossils around here. Now, after the dinosaurs died out, we get into the Paleogene. And we don't have too much right at the beginning, but moving on into about 50 million years ago, we get into the Eocene. And we've got some interesting fossils from there. This actually shows where the Gulf came up. This is not quite accurate. It should have water coming up about this far, because we know that the water made it up to Crowley's Ridge, and we know that because we got some fossils near Crowley's Ridge. such as ones from this guy. This is called the Choctaw giant aquatic snake, Pteris venus. And this is, it was a sea snake, but at least twice the size of modern sea snakes. Not something I'd care to swim with. We also found a Basilosaurus. And Basilosaurus is really interesting. It means whale lizard. The person who found it thought that it was a lizard that was as big as a whale. It turned out that he was wrong. It actually is a whale. But it's one of the very early, it's one of the first whales that actually has flippers rather than feet. So it has a very important position in the evolution of whales. Now, moving into the ice ages. Wow. I kind of thought this talk would be longer than this. Get into the ice ages. This is the Pleistocene. And we got the glaciers all the way up through here. They don't quite get down to Arkansas. This is in what's called the paraglacial zone. So we see a lot of things that were affected by the glaciers, but the glacier's not actually here. So if you can think of what the weather was like last week, and then make that most of the year, that's what it was like during this time. Now, some of the things that we find there, that we find during this time. Dire wolves. Now, I don't think anybody was making pets of them back then, but there are plenty of dire wolves that were in Arkansas. We also had smilodons, had these big saber-toothed cats. There's a canard fissure near Harrison. At least 15 of these have been pulled out of that. They apparently were using the. They didn't tend to live in the caves, but they did investigate them periodically. They might not have lived in them because bears lived in them. Among them, Arctodus. Arctodus is often called the giant short-faced bear, and it's known for having an unusually short face and very long limbs. Turns out that it doesn't actually have a particularly short face, and the arms aren't particularly long. It was just big. Arctodus, when it stood up like this, was 12 feet tall. So if you take the biggest grizzly that ever lived, the biggest brown bear that ever lived, couldn't look this guy in the eye. And so these are very large animals. It's been considered this is possibly the largest mammalian terrestrial predator. So Arkansas, not the safest place in the ice ages. So what do these guys eat? Well, one of the things they ate were giant ground sloths. Now these are really well known in California because of the La Brea tar pits, but they were here too. Now the ones in California were a different species. Those were Megatherium, and they were about 20 feet tall. These Megalonyx was another name for these is the Jefferson sloth, because Thomas Jefferson did work on these guys. These are only about 10 feet long, with really big claws. They actually use those claws mostly to pull down trees to eat, and probably defense. I would assume if you've got giant claws like that and some bear attacks you, you're going to use them. Another thing that we find is it's called Cervicus scotti. We call it the stag moose. It's actually not a moose. It's just a deer that's really, really big. And it's got very moose-like horns. Then we have mammoths. There was a mammoth found near Hazen. So we don't have a lot of mammoths, but we do know that they were here. Now the mammoths that we have in Arkansas were the Columbian mammoths. Most people are familiar with the woolly mammoths, but those were farther north, closer to the glaciers. Down here we had hairless, slightly less hirsute mammoths. The other thing that we find is mastodons. Mastodons were another type of elephant. These preferred forests, So we know because of the number of mastodons versus the number of mammoths, Arkansas was very heavily forested during this time. Because while we only have one good mammoth here, we've got a lot of mastodons. Arkansas has got more mastodons than any of the states around us. So, one thing that I get asked a lot is, where do you go to see Arkansas fossils? Well, probably the best place to go is the Arkansas Geological Survey. So if you talk to any of the geologists there, they have fossils stuck in all corners of their offices. They even have one or two small display cases. But they don't really have any place to store fossils, so they're just sort of piled up around. Not the best for public viewing. The most fossils you can see for them is if you're a teacher. Sandra Chandler there at the Arkansas Geological Survey has teacher kits that if teachers can come and ask for them and borrow them for their class, and it's free. So that's a good way to bring that a teacher can bring fossils into a classroom. Another place to go is Arkansas State University Museum. They've got it's the replica of one of the mastodons on display. The only problem with this museum is that they cover a lot of other things. The art, a lot of archaeology. The amount of fossils is really pretty limited, mostly to that skeleton, just a tiny bit more. You can go to University of Arkansas, either at Fayetteville or UALR, that have collections. Particularly the University of Arkansas at Fayetteville. They have very large collections. They have no museums, so they're stuck in a warehouse. So if you go up there, hopefully you might be able to find somebody to let you in and take a look through all the boxes. Not the best for public viewing again. One place that I didn't put up here is, right as I was about to say it, it just slipped my mind. Hate that when it happens. The best place to look for fossils is the Turner Neal Museum at University of Arkansas at Monticello. They actually have a whole natural history museum. And it's the only one in Arkansas. And so you can go there and see some stuff. The biggest problem with this museum is that it's hardly a good central location. People are not going to come to Arkansas to go to this museum. It's just too far out of the way. So, if you really want to see Arkansas fossils, the best place to go is New York. Because we don't have a natural history museum here for the state, almost all of our good fossils and a lot of our current samples get shipped out of state. The Ozarchus is at New York. Our saber-tooths are all at New York. When Dr. Peck taught botany at UALR, taught there for 30 years, he developed this extensive plant collection. When he left the school, that got shipped out of state. I think it's in Oklahoma someplace now. So, we have a slight problem here in Arkansas. I think we should scratch that out. We really need an Arkansas Museum of Natural History, because we don't have any place in the state that really serves as a depository of fossils or natural history, any other natural history samples. And that can be a problem because one of the things that a problem that we have right now is that most museums, when budgets get tight like they are right now, the collections tend to get cut. Which is really unfortunate because those collections are very important, particularly right now, because you can go to the collections and you can actually see climate change going on looking through the samples. And there's been a number of researchers that have done that, looking at different specimens and tracking how the climate has changed in those areas that it was collected. But yeah, we don't have any place for that here. So that is one thing that I am working on, is to try to get some interest into building one of these. So if any of you want to help, please let me know. That's my talk. If you got any questions? Yes?
Am I correct that Cretaceous was when the water came all the way up to the mountains?
Yes. Actually, during the Cretaceous, it went all the way up around the Rockies. So it basically cut the continent into two parts. Yes, it was much warmer back then.
Okay, so it's correct to tell people around here that if we go through another warming period like we did before, when the ocean was all the way up to Philadelphia, that's what we may be looking at eventually.
Eventually, it's possible. I doubt that it'd take a lot of warming to get the water that far up, because at the time there were no ice caps. So that's a good 200 feet of water or so. If both the ice caps melt, then we're going to get water all the way up to Little Rock. But Louisiana is going to be in a lot of trouble long before that. So. Let's just say that in the not too near future, New Orleans is not a good place to live.
But was it carbon in the atmosphere at that time that caused the water to be that high?
That's a good question. We do know that the carbon dioxide levels in the atmosphere were significantly higher back then. But towards the end of the Cretaceous, we see the carbon dioxide levels dropping, and coincidentally, we see the temperatures dropping as it goes through.
And that drop was carbon being drawn from the atmosphere, laying down seabed, which eventually became petroleum. What we're taking out of the ground right now. We're letting it circle here.
Yeah, all these things that that nature put into the ground, we're digging up. Actually, that's one of the things that I talked about the Epoch formation. The fossil fuel companies, they send their geologists here to Arkansas a lot to study rocks here, and one of the things that they study is the Epoch formation, because some of the shales there, they are so oil rich that if you get a good fresh sample, you dig off the top layer and you get a fresh sample, you can smell the oil coming off of it. And if you take a lighter, you can actually set it on fire, which is kind of weird watching this rock burn. Yes.
What was the
That was found near Fayetteville. Coincidentally, it's called the Fayetteville Shale that it was found in. So. You had a question? Yes.
What about human fossils? Have any been around before?
We'd have to talk to the archaeological survey for that. I don't deal with human stuff very much. That's actually one of the questions I get, is the difference between archaeology and paleontology. Archaeologists study humans, paleontologists study everything else. So we've got a bit broader of a territory. I do know that there was a boy that was found in Hurricane Cave. It's also where there was a Smilodon that was found there. It is up north. I forget exactly where. The Jasper? Yeah, I've been up there a couple of times, but I can never remember exactly where it is unless I'm looking at it on the map. Yes?
In our last talk, there was a lot of discussion of this attempt to insinuate creationism as alternative evolution. Do you run anything like that, like an attempt to insinuate 8,000-year-old Earth as an alternative to alien 60s? It's an alternative to paleontology. If I hadn't seen any bills like that introduced, in my own experience in high school was, we studied dinosaurs and all that stuff, and nobody ever tried to tell us that the Earth is 6,000 years old. On the other hand, when I was in high school, they didn't teach evolution.
Yeah, most teachers just avoid talking about it. About anything to do with evolution. They just try to avoid talking about it. Which is one of the primary reasons that people are trying to fight the next generation science standards, because that starts talking about evolution in like second grade, and they have to study it all the way through. They get just more and more complicated and more stuff involved with it. But they have to explicitly mention evolution, I think, by the third grade. So it's a really, I really like those standards, but there is some resistance to that. Of course, nobody in the legislature tries to openly put creationism into a bill, because everybody knows as soon as they do that, it's going to be tossed out. But they do try to sneak it in other ways.
It just seems to me paleontology has managed to escape relatively unscathed. And that's interesting. Why is it that the same people, like the Discovery, whatever, Foundation, isn't busy trying to insert 6,000-year-old Earth theories into the science curriculum?
Well, I think they do a little bit, but one of the reasons they don't really talk about it here is because nobody thinks of Arkansas as having fossils. But we do have a lot.
Because they're in a warehouse in boxes.
And that's one of the reasons why I think a museum would be really good, because we can put some of these things out in display and actually get people talking about it. One of the things I find really interesting when I go into classes and talk about the fossils, because I do talk about how old the Earth is and where these are in time. I've never had a kid complain, get upset. They've always been, I love talking to kids because they're always just so fascinated about it. They just love looking at the fossils, and they pretty much just accept what I say. The only people that I've had problems with are their parents. So. But kids are really nice. Any question?
I wonder, just this lack of an Arkansas Museum of Natural History, it could either be state-funded or privately funded. Since it's not state-funded, do you think they're just afraid of fossils in the legislature? Why would they think to do that? It's a matter of state property.
Yeah. They actually used to give a little bit of money to museums, but after the Houston hurricane, I forget which one that was, they zeroed out all the funding for all museums because they said it's just not important. So we're going to put the money into other things. Now, to run a museum like this, you're going to need both private funds, and fortunately, we've got a lot of really, really rich people in Arkansas. We've got tons more really poor, but we've got some really rich people that like to give money to things. But to keep it running, we'd have to have state support. Yes?
How does Arkansas rate as far as the amount of fossils, say, in the ground compared to other states?
That's a good question. Not as well as, say, Colorado or Wyoming. We have much richer diversity than both of those states, but they have a lot more. At least as far as people have found. The problem with Arkansas is that if you're digging for fossils, plants sort of get in the way, and Arkansas has got a lot of plant cover. So it's hard to dig for fossils here, and there has been no money spent in Arkansas to really do paleontological research. So all of it that's been done has basically been on private time of people that are interested in it. So it's been really hard. Yes?
You were saying that the predecessors to like the bear and stuff during the Ice Age, do scientists know why these predecessors evolved into what they are now, smaller species?
Good question. The general idea of it right now is that these large predators specialized on large prey. And at the end of it's been a couple of times during the Cenozoic, at the end of the last ice ages, a lot of the large prey disappeared. And so what you were left with was smaller prey. So the wolves, the gray wolf of today, can go after smaller prey a lot better. The dire wolves, they tended not only were they big animals, but they tended to run in very large packs. So it took a lot of big animals to feed them. When the big animals went away, they went away. And so now what we've got, the wolves have actually, in large part, not just because we've killed them, but we've killed off a lot of their prey. Of course, now we got a lot of them back, so we could actually support a wolf population here now. Nobody would allow that, though, which is really unfortunate because we found that it really hurts the ecology not to have these animals here.
Oh, it applies to larger prey, too. I mean, the key deer in Florida are the size of dogs. The deer up in Alaska are bigger than the deers.
All right, that's an interesting question. In general, that is true. It doesn't hold up as it's not a real. That's a general rule with a lot of exceptions. But it is true for a lot of things. Any question?
What could the Arkansas Society of Educational People in this room do to help to get an Arkansas Museum of Natural History started?
Talk to people. Get people's interest. I've got a lot of ideas. I am not if you want to talk to somebody that's really got money, I'm probably not the best person to do that. So if we had more people talking to the legislature, just bringing it up with people of influence, that would help. I've got, if you want to do more with it, please contact me. So I've been trying to collect names of people that are interested so that we can start getting something. I'm working on basically a business plan that I can show some of the potential investors to try to get people interested. I haven't ever really done one of these before, so if somebody who is really good at business and that sort of thing gets involved, it'd make it a lot better. Because I've got some really good skills. That's not one of them. So, question back there?
One thing to talk about here was that there's a lot of diversity in which geological layers are exposed in different parts of the state. As you mentioned, about everything in the Paleogene up to places exposed at various parts of the state. And presumably that was always true throughout the history of the Earth, that in different parts of the Earth there would be older layers exposed at the same time, and other areas more recent layers exposed. Now, when you have new deposits being laid of the animals that were living at that time, presumably wouldn't you end up having layers like, say, having Mesozoic fossils being laid out immediately on top of Paleozoic fossils, recent fossils being laid out on top of them, immediately on top of Mesozoic fossils, and others. Basically, the new fossils would always be on top, but there would be a lot of skilled layers.
Right. Anytime that you've got the layers exposed and you start eroding down, so there's a lot of places that it's like the Permian and Triassic and Jurassic. Those rocks were laid down, but they've all been eroded away. So the later rocks were deposited on top of them. So you can't really go to any one place and get the full sequence, but it's pretty easy to correlate sequences across the state to get a good sequence.
So you're going down through the layers, you often find places where multiple layers you'll find a whole big chunk of geological history missing because that area has been eroded away. So the next layer starts moving up.
Yeah. The Ozarks are really nice because that was just basically a smooth lifting up. So while the rocks are bent, they're all in a nice order. So you can just walk through time as you go through the layers. The Ouachitas, unfortunately, they're all broken up. There's a lot of faults through them, so it's a lot harder to actually go through things that are like that. But the Ozarks are great for that, which is one of the reasons probably why we get so many more fossils up there than any place else. You had a question in the back?
As a follow-up to the question about the size of animals, very different sized deers and such earlier, in your opinion, is there any correlation with the disappearance of the North American megafauna with the appearance of humans?
Yes, there is quite convincing evidence of that. Pretty much any place in the world that you go, particularly in North America, when humans get there, the megafauna disappears. Humans don't like to share. There is a lot of debate about that. There is certainly climatic influence, but it's really hard to pin all of it on the climate. So it's almost guaranteed that humans were involved in it. One of the problems that we have is that people like to have, cause was this one thing, and that almost never happens. Really, it's usually a confluence of factors, and so we do have climate change going on, but we know we had humans hunting, and they hunted at extreme, absurd levels. There was a place I went to in Colorado. They actually had evidence of people running mammoths off of a cliff and just piling them up at the bottom of the cliff, and then they'd take what they wanted. But they'd kill off a dozen or more at one time, and there's no way they used all of that. They also probably one of the things that they did that affected the megafauna the most was agriculture, because agriculture really wipes out the natural forests and that sort of thing. So as soon as you get agriculture into an area, you actually start seeing climate change. So that's part of it. Any other questions?
Those Ouachitas were uplifted, weren't they?
The Ouachitas were uplifted some. Their primary part was crumple zone from Africa. So that's one of the reasons if you go to look at the Ouachita geology, it's all cut up. Any other questions?